All right, let's jump right in. We're going to talk about a massive challenge that pretty much every big tech company has to solve. How do you handle an API that needs to return just an insane amount of data? We're talking billions of products on an e-commerce site, millions of posts in a social feed, basically an infinite timeline. How do you make that scrollable without, completely crashing the whole system?
I mean, think about it. It's an experience we totally take for granted now, right? You're scrolling down an endless list of products, and it just works. But behind that super simple action is a really smart engineering solution that's designed to stop everything from blowing up. Today, we're going to pull back the curtain and see exactly how they do it. So, the magic behind this whole thing is a concept called API pagination. It's actually a pretty simple idea. Instead of trying to send you like a million things all at once, which would be a total disaster, the API chops up that giant data set into these little bite-sized pieces. We call them pages. Then your app just asks for these pages one by one, right when you need them. And the reasons for doing this are, well, they're fundamental to making the internet work. Without pagination, servers would just get crushed trying to handle these enormous requests. Your phone would be choked with data, and the app itself would just freeze up or crash. So pagination is the unsung hero that keeps our favorite apps feeling fast and snappy. Okay, so how do you actually do this? Well, the first method most developers try, the most common one you'll see out there, is called offset pagination. It's the most intuitive, straightforward way to get started, and honestly, it's everywhere. The logic is actually kind of beautiful in its simplicity. You just tell the server two things. First, hey, give me 10 items. That's your limit. Then for the next page, you say, okay, give me another 10 items, but offset by the first 10 I already saw. You're basically just telling it how many items to skip before it starts counting. And that right there is why it's so popular. It's just so easy to understand and quick to code up. If you're building a new feature or maybe a smaller app, this method gets the job done without a lot of headaches. But, and this is a big but, that simplicity comes with a really high price, especially once you start to grow. And this is where our simple story gets a lot more complicated. That nice, clean solution starts to completely break down under pressure. So let's dig into the two huge ways that offset pagination can fail, and it usually happens at the worst possible time. So here are the two big villains of our story. First, there's a major performance problem. The deeper and deeper you scroll, the slower and slower the whole thing gets. And second, there's this really frustrating consistency problem. In a fast-moving feed, you can actually end up seeing the same post twice, or worse, missing one completely. Let's really break down that performance issue. Imagine you're asking for page 1000, with 10 items per page. That means you're telling the database to skip the first 9,990 items. Now, the database can't just magically teleport to that spot. Nope. It has to actually scan and count all 9,990 of those items from the very beginning, just to throw them away and give you the 10 you wanted. This gets incredibly slow, really, really fast. Okay, now for that consistency flaw. This one's a bit more subtle, but it's just as bad for the user. So let's say you just loaded the very first page of your feed and you see 3 items, A, B, and C. So far, so good, right? But here's the thing, your feed is live and constantly changing. In that split second, before you scroll down and ask for page 2, a brand new post shows up, and it gets added to the very top of the list. Suddenly, the entire dataset has shifted down by 1. So when you ask for page 2, which your app translates to skip the first 3 items and show me what's next, the database dutifully skips the new item, item A, and item B. And what's the first thing it gives you? It's item C, which you just saw on page 1. This is a perfect example of how you end up with duplicates and a really broken experience for your users. So if our simple fix is actually pretty broken, what's the real answer? Well, this is where our hero enters the story. A much better, much more robust solution called cursor pagination. It's specifically designed to handle the scale and speed of modern apps. This is the key aha moment. Instead of telling the database how many items to skip from the beginning, you give it a unique identifier from the very last item you saw. We call this identifier a cursor, and it works exactly like a bookmark in a book. You're no longer saying count 10,000 items. You're saying find this exact bookmark and start reading right after it. So how does this work in practice? It's actually a really clean little cycle. The server sends a page of data, and with it, it sends a cursor that points to the last item in that batch. For the next request, your app sends that exact cursor back to the server. The server then knows exactly where you left off, and it fetches the items that come right after that cursor. It's a really efficient back and forth conversation. And you can see how the Menifix here directly fix the problems we had with offset pagination. Because you're using a stable bookmark, it doesn't matter if new things get added to the top of the list. Your place is saved. That solves the consistency problem. And performance? It's lightning fast, because the database can use an index to jump directly to your bookmark without counting anything. This makes it absolutely perfect for those demanding real-time apps we use every day.
So we've looked at the simple but flawed way and the more complex but rock-solid way. Let's wrap this up and give a clear recommendation on which one you should actually be using. When you put them side by side like this, the trade-off becomes crystal clear. Yeah, offset is simple to build, I'll give it that, but it pays this massive price in performance and consistency as soon as your data starts to grow or change a lot. Cursor pagination is definitely more work up front, but for any serious scalable application, it's really the only way to go. And that brings us to the main takeaway. The one thing to remember from all this, if you're dealing with a large data set, or one that's changing all the time, like a social feed or an e-commerce store, or even just a bunch of logs, you really need to use a cursor-based approach. That extra work you put in at the beginning will save you from so many headaches down the road. It is absolutely worth it. So as we wrap this up, it kind of leaves us with a really interesting question to chew on. This whole story of offset versus cursor is a classic tale of a simple solution that just doesn't scale. So it makes you wonder, what other quick fixes do we all have in our toolkits that might just be hiding similar traps, just waiting for us to grow? It's a great reminder to always be thinking about the future.